We're group 7. We're going to work number 8 from the sample C exam. So we're given that one, claim counts follow a Poisson distribution with mean theta. So we'll say that N is Poisson with the mean theta. 2, we're given claim sizes follow an exponential distribution with mean 10 theta. So we'll let X denote our claim size, and we'll say it's exponential with mean 10 theta. 3, claim counts and claim sizes are independent given theta. 4, the prior distribution has probability density function. Pi of theta equals 5 over theta to the 6th power, given that theta is greater than 1. And we need to calculate Bowman's K for aggregate losses. We'll explain what that is later. We'll define our aggregate losses as S. And well, I'll tell you what K is now. K is going to end up being the expected process variance over the variance of the hypothetical means, and we'll explain what that is later. So first, what we're going to need to do the problem is we're going to need to find the hypothetical mean and the process variance. So the hypothetical mean will denote mu of theta, and that is equal to the expected value of the aggregate losses given theta. And I think we learned this equation in the J class. To find the expected value of aggregate losses, you find the expected value of the number of losses and multiply that by the expected value of the size of the losses. And given that n is Poisson and x is exponential, and from our tables we can calculate this to be theta times 10 theta, and that's 10 theta squared. The process variance we'll denote as sigma squared theta, and that's going to equal the variance of our aggregate losses given theta. And again, we learned this equation in the J class. This is equal to the expected value of the number of losses times the expected value of the squares of the sides of the losses. And that is, from your tables again, going to be equal to theta times 10 theta squared times 2 equals 200 theta cubed. All right, now Alan's going to tell you how to find the population mean.
And now we're going to find the population mean, which is the expected value of the hypothetical mean, which is and that is the integral from 1 to infinity of 10 theta squared times 5 times theta to the negative 6th, which was the prior distribution PDF. And that simplifies to 50 times the integral of theta to the negative 4th, which simplifies to negative 50 over 3 theta cubed from 1 to infinity, which just becomes 50 over 3.
All right, so now we want to find EPV, which is the expected value of the process variance, which we found before. So this is the integral from 1 to infinity of 200 theta cubed times the PDF of our prior distribution, which is 5 theta to the negative 6. And now we take out our constants and simplify. This is theta 3, and this is negative 1,000 over 2 theta squared from 1 to infinity, which is 500.
Now we need to find the variance of hypothetical means. And we found that our hypothetical mean was 10 theta squared. So we need to find the variance of 10 theta squared. In order to do that, we need to find the first moment and the second moment. So we need the expected value of our hypothetical mean squared, that's our second moment, minus the expected value of the hypothetical mean squared. That's just the variance formula that we all know. So we already have this. We found our population mean. We found out that was 50/3, so that's just 50/3. So then we need to square it. For this one, we're gonna calculate the second moment. And to do that, we're gonna take the integral of what we want. We're gonna square it. And then we're gonna multiply by our prior distribution. Just 5 fit into -6. Okay. So then simplifying that, we come out with 500 integral of theta to the -2 d theta minus 50/3 squared. This integral works out to be -500 over theta, evaluated from 1 to infinity, minus 50/3 squared. And in the end, this works out to be 222.22. Okay, and then if you remember, we were asked to calculate K, which is our EPV over our VHM. We've calculated both of these things. So to calculate K, we just need to plug in. Our EPV was 500, remember that. And then our VHM to give us a final answer of 2.25. That's it.